Hey, John, welcome back. How the heck are you doing, man?
I'm doing fantastic, Chris. How are you?
Oh, I so much better. I'm so sorry for
Yeah.
canceling a couple weeks ago. That was a rough day for
Well,
me.
I don't think we should have done it from, you lying down in bed, looking up at the camera through one sleepy eye. Yeah, I was glad to see you're feeling better.
Yeah, we are back on it, and
Yeah.
honestly, so this just last weekend I was at Sequel Saturday. Uh, have you ever been to Sequel Saturday before, John?
I haven't.
Oh, it's fantastic. A whole bunch of great people got to talk about data in all sorts of different places. I brought up Data Vault so many times. Uh, Hopefully, some people will remember that and will watch the live stream because I'm super excited
Yeah.
about this demonstration. So,
Yeah.
yeah.
No, that's great. Yeah, hopefully, we can go through and just kind of show one easy way to deploy some of this stuff. There's a lot of ways to skin that apple, but
Well, and I'm excited to see that we have in the chat we have Paul Turley with us. Hey, Paul, because
hey, Paul, long time.
yeah, I heard Paul Turley does not like Data Vault. I heard that, and we actually have a graphic on that. So we're going to see if we can change the mythical Paul Turley's mind on Data Vault here, because I think this is going to actually be able to do that because I'm very impressed by this. So
Well, it's not whether or not you believe in Data Vault. It's Data Vault believes in you.
yes.
So,
Oh, that is so true. It's good to see everybody joining in today. So if you were here the last time, uh, we uh, we went through an overview of just like what the heck is Data Vault, right? Like,
mhm.
and that to me when I first looked at it, I said, "Nah, this is way too much." It was too much. I was thinking about it at the gold layer, but then it was reframed. You said, no, this is a silver layer management, so I'm not losing any of
Yeah.
my data. And I just went,
Mm.
holy cow. Yeah, and Paul's coming in saying,
Yeah.
yeah, he
Of
just
course,
wants
we
to know.
can always get along. There's no this versus that. I can't stand that framing, but it is, it's one of those. In some situations, this is a great tool to use. It
Yeah,
makes sense. And in this little sample application we're going to walk through in a minute, I created demo tables. I created a fake set of tables. Data Vault makes no sense for this. It makes
yeah,
no sense for these. If you had this tiny little thing, but this is just a mechanism to show you how to build it. But you would need a specific sort of data climate for this to thrive. Like it wouldn't necessarily work if you have just a small number of relatively steady source systems. It doesn't really make sense for that. Like why go through the hurdles if you don't have to? But if
yeah.
you have a lot of sprawling integrations to make and you have to maintain a lot of changes over time, then yeah, placing this in the right layer, like you said, Chris, I wouldn't put this at the gold layer because when we get to it and you see like I created a small star schema on top of this, the number of joins would drive you mad. But it does work when it's kind of staged in that delivery between source and gold. But
No,
yeah,
that's fantastic. So why don't we go ahead and I got rules. We have rules.
yes, gotta have
So
rules.
first off, this is supposed to be a design as a conversation. So please prefix any questions with a Q so I can get those queued up so we can address them. As always, we follow God in the Q, Matthew Roche rules. So we do that. Please don't spam any questions. We don't want to, just take over the chat. We're pretty good here. We're not like a huge crowd, so that should be very easy for us to do. And then because I think we're going to get into this, and I don't want to forget about this. Just as a reminder, next week, Marco Russo will be on. We're going to be talking about the value of best practices. Why are best practices important? We're going to like dig in on that side as to like why we should be doing all of these things that we talk about. So super excited to have the man, the myth, the legend on the show. So be aware that that is coming up. But I'm going to get into this. So this is our lunch and learn. So everybody, grab your beverage, grab your sodas, grab your slice of food or whatever you got to eat along with us. And as we dig into this, let's grab our communal sip so we can get started.
Oh, yeah.
All right, John.
Made elegant work of that. Okay.
Let's head over to your laptop and let's get started.
Yep. All right. So I think the first thing we want to dig into is this was what we're doing is building Data Vault using DBT. Now, we went through the Data Vault portion of that that statement last time, and then this time it's just let's go a quick refresher for those watching who aren't familiar with DBT. It's an open source modeling layer that you put in place. It is the T in ETL or ELT. It doesn't move from A to B. It does not transfer data. It connects to your warehouse. It connects to Snowflake, Redshift, or Postgres even, and it transforms data in place. And what it does is it's a code first tool. So you're working out of basically a Git repository or a GitHub repository. That directory is your project, and that's how DBT knows where to put things. But it takes data transformations in the form of SQL or even Python files, that's a new development in DBT, and it turns them into database objects within your warehouse. So you're not maintaining DDL. It simplifies this process. It also has a lot of features built in for built-in testing and documentation. So if you want to have like your generic or kind of specific testing, you can write certain business logic to test things that you need to make sure your data model satisfies. There's also the presence of macros, which is what we're really going to get into in a second here, which you can script out kind of code modules so that you're not repeating your code if you have a very specific set of rules that you need to follow. And the more complex these macros get, sometimes people will package them up and deploy them to DBT's package hub, which is what we're going through today. So I can't remember how many years ago, like a few years ago, it used to be called DBT Vault, but now it's been brought over by this company, Data Vault UK, and turned into Automate DV. So Automate Data Vault. And this is a package that we're going to be stepping through so that we can build out a Data Vault layer using a DBT project. So we'll go through. So the Automate DV package, it just enables you to create models that are necessary to run Data Vault 2.0. So you can see that we have, there will be Jinja code snippets that you're going to call, and you're going to have to set up pieces of metadata. It's going to call for a source primary key, your source natural key, and it lines everything up so that it says, okay, these are all the elements you need for a hub. These are all the elements you need for a satellite, a link, etc. And it will also help you create that staging table that will serve to kind of create the basis for all the data vault layers. So because hubs, links, satellites are all kind of sourced from the same raw or source layer or stage layer, they can all be run independently. So the stage macro that we're going to call, you pull up your source model, you define.
Hang on one second.
Yeah,
hang on one second here. I just want to make sure I'm framing this up correctly. So, DBT is a tool that allows me to manage my data assets that are inside of my data lake. So I can use it to create my my gold or my silver, my gold, my diamond, whatever layer.
Yes.
I can create data assets with that, right? And
yes,
it's super popular amongst enterprise companies and smaller companies because of how easy it is to work with, right?
because what it is it's modular. You can deploy this on specific elements of your data warehouse. It doesn't have to run the entire thing. It's not going to be and you can run an end-to-end enterprise data warehouse, but you can also have projects that are focused like domain specifically.
Sure. And I think one of the reasons why a lot of companies really like it is because it works for both IT, and it's very easy for the business to take on too in a lot of cases, right? Because all
Mhm.
you have to do is basically know some SQL and you can get up and running in that. Is that right, John?
Pretty much, yeah. Like the thing that you're writing is select statements.
Mm.
So this handles the the inserts, the drops, the creates. You really need to know how to create a well formed kind of select statement so that you can just model a table and it will then create that table for you.
Oh, that's fantastic. And it's these modules then that help not
Mhm.
just in creating those select statements, but help in shaping our entire
Yeah.
data vault. Is that right?
Right. And so yeah, and the terminology they use is models. So
Oh,
every
models.
file is a model. And
Mhm.
I misspoke as well. But it was so these every kind of model it and because it uses Jinja as kind of a referential tag, you will reference dependent models. So you don't have to worry about what order to call things in. It will know what the reference chain is. It builds a dependency graph before it even runs. So it knows that if this model is upstream from this one, this model has to run first and then the next one can run.
What does that have to do with redheads? Gingers? Didn't know that.
I'm trying, Chris.
Yeah,
Really trying.
sorry. Sorry. All right. So, so that, and that's the other thing I love about it. So when
Yes.
you drop in your SQL, you create that module, it
Yeah.
knows all the dependencies and when to run it, right? So,
That's right.
oh
Because
gosh.
yes, because it's repository based, it runs through the directory and it says these are all of my models.
Hmm.
Okay, let's grab all the tags out of them and then build the chain so that we know what order to run everything in. So when you actually just call, because it's a two-word command, when you want to run things, that's right, Paul. When you want to run things, it's it knows exactly what the dependent models are because it can parse out that tag and then stage it everything every time. So
That's fantastic. So what we're talking about is we're talking about
mhm,
using a tool that's very easy to use, that does a lot
mhm,
of our heavy lifting for us.
yeah,
That all we have to do is like know our SQL, learn a few other things, right? Like how to
yeah.
work with it. It's a little bit. We're not talking a big lift here. This
We're
is
not talking a big lift,
yeah.
but what you are doing is working. You're working more in code than a
Hmm.
UI.
Yep. Yep.
Now, so DBT started as a command line utility. So you would basically install it as like a pip
Mm,
Python
okay.
library you would install. But they also now have a cloud hosted version. That's what we're going to be working in today because
Okay.
it's just easier to kind of step through and demonstrate rather than watching me pull up a bash terminal. So
Well, fantastic. And
mhm,
I will say that they've also there's a they just came out with the DBT and Fabric integration, although
mhm.
I understand the Automate DV does not yet work with that, but I'm
No,
sure
not
soon
yet.
enough, right?
Yeah, it's so right now this one is limited to I think BigQuery, Snowflake, um, maybe SQL Server. Yeah, not a ton of them.
Okay.
But it is going to probably be expanding over time.
Yeah, and that's
Yeah.
perfectly fine. A lot of people work with Snowflake and these other tools, right? Like perfectly
Mhm.
fine, right?
Yeah, absolutely. Well, yeah, because DBT, when it was founded, it was really Fishtown Analytics was the company that created it. They built this as a Snowflake utility.
Hmm.
So it was designed for Snowflake originally, and then it's been expanding outward since.
Yeah, and honestly, if you're working with Snowflake and you're not using DBT, that seems like a challenge to me. But all right, let's
Yeah.
keep going. Sorry,
Okay.
sorry, my
So,
recap there
no. I'm glad you
derailed
did
you.
because yeah,
So
no. I had my foot on the gas there, so that's good.
okay.
So as we're going, so I'm going to back up a little bit. So to talk about Automate DB, we're going to be looking at there are basically four macros in this package: stage, hub, link, sat, and these are macros that you're going to call, and you have to pass in certain metadata to build the objects. And what we're going to do is kind of demonstrate how it will compile the SQL necessary to create these things. So you're just passing in metadata to these macros, and it's going to compile the SQL for you. So first, the foundational piece is going to be stage, and this is where you grab your raw source models and say, these are going to be the hash keys I'm going to create. These are my business keys. We're going to identify these columns. We're going to identify what the record source is, what source system. We can identify the load timestamps. So these are all going to be crucial metadata columns that will kind of be persisted in the data vault layer. And then there are a couple of others you see in this code snippet here. Like, you can specify which null business key columns you have. I haven't quite gotten that the use case for that one worked out, but you will have hashed columns and or ranked columns. But we're going to work with a pretty specific, really simplified version of this. And then after stage, you will then, on the output of these stage models, you're going to be building your hubs, links, and satellites. So for hub, you're really going to be setting the keys, because as we talked about last time, a hub is just a collection of your business key unit, and it wants to track this is the identified record for this customer, this order, this product, etc.
Sure.
Yeah. And so going through, we also have the link. This is again, this is where we're going to set up our foreign keys. This is how this hub is linked to this hub. This is the relationship between these two business keys. So, if a customer makes an order, we're going to have a mapping table, essentially, is what this is going to turn into. And we will track if there's going to be any extra columns that are associated to that. This will kind of stagger that into the SQL so that we pull in the complete table, not just only the key columns.
Okay.
Yeah. Yeah. Same thing with satellite. The satellite column, think of it as your type 2 dimension. Your slowly changing dimension. That's how these are designed. So you're going to be having your primary key and then a hash diff so that you can identify what a changed row is. And so what's interesting about this is you can set up the list of columns that go into your hash diff. If you want to say these are the columns that if anything in this set changes, the entire row needs to be updated.
Okay.
Yeah.
And this is all generated by Automate DV, right?
Yes. So yeah, the SQL will be generated by Automate DV. So it will, and I'm going to step through, because what we're going to do is we're going to fill out a few examples of stage table, hub, and link, and then we'll compile the SQL so you can see exactly how it's built.
Okay. Awesome.
Yeah. Yeah. So this is our source play schema for give whatever fake company name you want. But really what I did was I created, and I'll show you the tool that I used to create this in a bit, but it's a tool called Makaru, where I basically generated about 9 fake schemas, gave them some, weird, they have some predefined data types. So I just had to generate 1,000 rows here, 1,000 rows there, so that we would have something to load into Snowflake and use as our source system. So what we're going to do today is take this raw schema and turn it into this, which is going to be our data vault model, where the hubs are coded in blue here. Those are linked together with our orange link tables. The satellites, and I have 2 different flavors of satellites here. The hub satellites, which are really just kind of the descriptive satellites for hubs. And then there's a link satellite, that's a descriptive table for facts. So the link table here is really just going to have the correlation of the keys, and then we're going to have our transactional information. The details are going to be in that sat link card item. So when we get down to it, this is really going to be our fact table when we look through.
Okay.
Okay.
So, looking forward to it.
Yeah. So yeah, why don't we
all right. Enough with the slides.
Enough with down with PowerPoint, up with my browser. So again, this is Makaru, just to give you an idea. This took me about an hour to build. And what you can do is just type in any one of your data fields, and it'll show you. You can just pick a whole bunch of different pre-built data types, and it'll just generate mock data. It'll generate a ton of fake email addresses, phone numbers, what have you, so that you can just have something to work with.
Okay.
So, and then, we're working in Snowflake. So I've just kind of built this data vault demo. Now the raw data, I loaded all of those 9 tables right in here. So this is going to be kind of our source that we're working with. And now let's go into our DBT project. So before we get into kind of our template code that we're going to step through, I just wanted to point one thing out here. So when you're defining a project in DBT, this is kind of your base code. DBT Cloud, as I set up this project, it created this for us. But okay, I gave it some
zoom
more.
In on that so we can see that a little
can.
better. That'd be great.
So this kind of top section of the code, what it's doing is it's pulling all the directory to the right here in the file explorer. It's pulling every one of those folders and mapping it to, okay, this is where the models live. This is where my tests live, my seeds, macros, snapshots. It really does kind of structure it in a way that you can collaborate with a lot of people because you're all working out of the same formed repository.
Yeah, this is fantastic.
Yeah. Zooming in one more time. Chris just taught me how to use this Zoom tool, so I'm still getting used to it.
It's day 1 with Zoom It, so it's okay. Or hour one with Zoom It. You're learning.
Literally installed it 2 minutes before we went live. It was a lot of fun. So, but as you see here, so lines 19 through 28, I'm actually specifying several things here. So I'm pointing out the 4 directories where all of my subsections of models. So my raw models, my stage, vault, and marts models. And this materialized configuration, DBT allows you can materialize these objects in a number of different ways. A model in DBT, as a note says, it's not just a table. You can materialize it. Its default is a view. So it'll create these select statements as views by default, unless you specify something else. Table is, what I have here is I want these kind of raw models, and I'll show you why in a second, to be views, because they're really just logical call outs of the source table. And then stage and vault, I want those to be physically deployed, as I want the data to be loaded into a table and instantiated. Whereas the marts, I want the facts and dimensions to be views that sit on top of my data vault layer.
Okay.
And so this is where you can specify this. This is doing it at the directory level. So any model that is built in one of those 4 folders is going to adopt that, is going to inherit that configuration, unless in your specific, if I were to put a configuration at the top of this model to say, make this a view, it will override.
Okay.
So
that just could be the generic, how it's going to treat it. It's going to be what you define here, but you can override that at a lower layer. So if you needed to materialize a view instead of a fact table because let's say it's not performant, you could do that, right?
Yeah, that's right. That's exactly right. And there are a few other ways. There's actually one called an ephemeral model, which is essentially you can build a select statement and it will treat it as though it were a with statement, a comma table expression. And so it doesn't ever build it in the database. It just will load it as a model to be referenced by other models and then discard.
Okay.
Yeah. So that is the quick and dirty version of DBT project. The next piece that we're just gonna, when you want to go install it, you have this YAML file for packages, and in here I've said, okay, I want to pull in this Data Vault UK Automate DB. What this knows to do is to go to the package hub. It's a built-in thing. So when you run the command dbt build, it runs all your dependencies. It runs the whole package install process, and it will go pull all of these packages into your repository so that they're available for use. And yeah, so under here we have the Automate DB package, and this is where all of our macros are living. So we're going to go call this one here in a second. But now let's go step through our models. So let me clean up the view here a little bit. So in the raw models, I'm referencing these as select star from the source table. So this, if we were to compile this code here, just go to compile. This is just going to spit out the SQL that is then issued to Snowflake, which is just select star from data vault demo raw address.
Okay.
Okay. So right. So right in here, it's basically going to go pull from this table. It knows to go do that, and then from there we can build our stage models off of that. So I want to turn that raw address table into my stage table. Well, in here we already have one built, and I just completely overshot it. But I thought for our exercise we could actually rebuild the stage cart, which is we have this automate DB stage call. So this is the template call that you have, which is, you have to set these, set all these variables. And so I thought what we would do is just step through the code a little bit. Now this one's going to be a little code intensive, but the first thing we're going to do is set up a YAML block in this, at the top of this script here.
Module? Okay, script.
In the model, yes.
Yep.
Thank you.
No problem.
So first, what we're doing here, this is a Jinja block. Not ginger, ginger. Jinja. Tell me, this word here. We'll zoom in so you can see.
Jinja.
That's right.
I am Jinja. You are Jinja. We are Jinja too. Isn't that?
Right. Yeah. I'm not sure where we're going with that.
You didn't remember? You never saw the I Am Ninja YouTube series?
Probably not.
Oh, it was popular a
man.
decade ago. I'll find links and share it. It's funny. You should check it out.
Okay.
Keep going. Sorry.
So at the top of this, what we're going to do is we're going to define a variable called YAML metadata. And I have some helper scripts in here. But this is going to be a code block. So I've started the definition, and what I want to do is be able to do this on multi-lines. So end set. So right now what we're going to do is we're just going to write out a YAML block so that can be used down the line, and we can call that into a metadata dictionary. So what we're doing now is source model. This is going to be our first definition. And we want this to be our raw cart table. So this is going to be the table we're referencing. So it's a 3-column table. There's not going to be a whole lot in this hub that we're going to pull up. A cart. And the next thing is going to be our derived columns. So what are the columns we need to add on to here? And that's going to be our load date timestamp and our record source. So derived columns. Source. Raw cart. So what's going to happen here is when this table is created, it's going to tack on a new column called record source, and it's going to put this explicit value in there. So we're defining what the value of that column is. And then the next one is going to be load date, which is going to be a very simple, as you can see, we have a timestamp column in here called created at. So we're going to use that as our, I meant to disable my notifications. Apparently I didn't.
It's all right. We'll forgive you this once.
Thank you, sir. All right. So what we're going to do is reference the created at column. So now that's going to take that created at and snag that as our load date timestamp when we go to build the hub and all the downstream tables.
Okay.
Next, we want to hash our columns. So the hash columns are going to be, so we have 2 kind of key columns in here. So we have the cart ID and customer ID. So we're going to call those our cart PK, cart primary key. That's going to be referencing cart ID. And then we're going to have our customer PK, which references the customer ID.
Okay.
So the one thing we're also going to want to take into consideration is we're going to want to link these two. So we're going to need a primary key for that. So we're going to hash these two together in the link cart customer. So this will be used downstream in the link table when we walk through. I'm not going to make everybody watch us build everything from scratch. I thought ahead.
Always thinking.
Yeah. Cart ID, customer ID. So what's going to end up happening here is it's going to concatenate these two columns as a single hash column.
Okay.
All right. So I believe I'm looking off my notes over here. I think that is it. So we have passed in everything that we're going to need here. So I'm going to save the model and let's compile the code so we can see what happens when we pass in all this metadata into this macro. What does this look like?
Okay.
It's going to look like an error because I mistyped something.
Wah, wah, wah.
Yeah. No, what I forgot to do is I forgot to actually parse out the variables. So bear with me. We're going to have to set the 4 variables that need to be passed in. So data dict. So this is from YAML module or method where we're just going to pass in the YAML metadata variable that we created earlier. So now we have metadata dict available to pass in our source variables. So now we can create a variable source model equals metadata dict.
Hey, Christian, welcome.
Source model. And then derived columns is going to be the same thing. So just instantiating the rest of these, and then just one more, which is our variable names, and the last one is going to be hash columns. So what we're doing is this is referencing each one of these kind of parent tags in the YAML so that it passes in all of this information below. So
Okay.
once we pull that in, now this should compile and give us nothing like doing it live, huh, Chris?
The demo gods are here.
Yep.
Super easy, barely an inconvenience.
I know, right? Yeah.
There we are.
Fantastic. I love my job.
Well, I mean, the good thing to see is number one, you know, it's not like you're recoding everything here. We're just coding in some of this, but it's not an impossible thing, right? Like you didn't code hundreds of lines; that were 4 lines. So
yeah. So again, you know, let's step through what we just created. So what's happening is it's taking it's generating a series of CTE expressions. So it starts with your source data, and then it applies each one of those steps that we defined. So the derived columns, the hashed columns, and then it's going to essentially build out the entire stage with all of that stitched together. So, as you see, the source data is pulling from the dev raw cart, and then it adds those two. It adds these two columns that we have here, which is the record source created at load date. So it's going to stitch those in, and then this is the part that is always the pain to code. But now it's going to create our hash columns for us, and it's going to create all the syntax, going to stitch together multiple columns if need be. Because what you really have here is it's concatenating everything that you need into one column for you, so that it just spits it out. And then it does the one thing that I'm always puzzled with DBT is it wants you to create one last common table expression and then a select star from it, which is, I kind of feel like it's an unnecessary step, but that's there are arguments for it. But again, what ends up happening is you can then issue the SQL back to Snowflake, and this is what the table will look like when it's finished being built. So So now you have all your everything is then built, and so what I'm going to do now is, because I now have all my stage tables built out. And they actually do exist now, because I went ahead and did that before the presentation. But we can now jump into the hub, if it'll let me drag the screen down. The hub. And so we're going to do the same thing, kind of but in a much, hopefully, quicker fashion. So we just have to, now we're not setting giant YAML blocks. What we're doing is we're setting the variables that have already been kind of set up in stage. So set source model, and we're pulling this one from stage cart that we just finished building. And then the next one is going to be our source primary key, which we also just built. Source PK, and that's going to be the cart PK column that we built in that stage table. So the natural key is it's going to be the same thing. Card ID, because we want to actually have this digit number showing up. And then we're going to add in the last two metadata columns, which is going to be our load date timestamp and our record source.
We got good feedback, just for your aware, in the chat about people like seeing the live development, right? Like,
that's good.
It can feel like it's taking a long time, but actually, as you're typing, people are reading it, and they're absorbing it, especially if they haven't done it before, right? So
yeah, right. But again, I think what the fun is here is to be able to say, well, let's compile this and let's see, what this automate DV hub method we're calling, because all we're doing, this is code you can go copy directly from the automate DV documentation site. They have these templates out there. So you can just grab that and say, okay, well, I got to line up just all these variable names into these. Well, what happens when I do that? And let's compile it. And oh my God, first try. It's amazing.
Yeah.
So again, what, right. So step one here is, it's pulling in from the stage cart table, the 4 kind of key columns that we're looking for. It's grabbing, wow. I forgot to hold down the control.
No problem.
So, it's pulling in these 4 key columns, and then what it's doing is it's gonna number them by the cart PK, just in case. Let's say you have multiple iterations. So in that stage cart table, if you were pulling it from a little bit more of a detailed table and it needed to group it down to cart, well, it would rank it and then only pull out that number, that primary first record, or like the most recent record, or whatever the latest loaded was.
Sure.
And then from there it pulls out the records to insert, which is give me that set of cart records that we defined as the hub table, and we're going to put that into what is now our hub table, which now looks like this. So here you have your cart primary key. This is your natural business key, load date. So very simple setup on this one. But okay, so now I think the next one, let's quickly build a satellite on top of this one. I picked the smallest table to build, but I also want to watch our time here.
We can run a little bit longer. We started later. Sorry for the delay. Start, everybody.
So we're going to set the source model again. So what we're doing is we're trying to create the kind of payload table for this cart hub. So we're going to pull it from stage cart again. And we're going to move right along. The next one is we want to set that source primary key. Cart PK. Now we're going to call up that hash diff column that we made, so that it'll know what the unique identifier of this row is. I believe we called that one cart hash diff. Payload is going to be the next one. What's fun about DBT is it kind of picks up everything you've been typing up to this point, so it can bring you up a little menu of things that you might be typing later. It just kind of a little predicted that way. So this one gets set as an array, and it's going to be a single item array. But this is where you could actually throw in every single column. So let's actually throw in the created at as well, just for fun, even though it's already the load date timestamp column.
Okay.
And source effective date. So because these are kind of loaded as a type 2 slowly changing dimension, this is going to be the date key it's going to key off of to insert new records based off of this date. It uses the load date timestamp for that value.
Oh, I gotcha.
Mm-hmm.
So,
but there could be different business rules. Like, let's say there is an effective date versus a load date that's tracked in your system. Again, we're working with a very very basic. This is basic cable. I'm going to have TBS on this one.
do you remember where they added TBS to basic cable?
Oh, it was the best. I got to watch like Spies Like Us 9 times in a row. It was great. Those are the best. When you're homesick from school, I don't know why that movie was always on. It was like chicken soup. So good.
Why don't you gentlemen try a Pepsi?
B.B. King's best line on screen. Won't you gentlemen have a Pepsi?
Yeah.
Oh, Colonel Rhombus. All right. So now it's...
Sorry.
No worries. So, all right, let's quickly compile all this. So what, again, I kind of quickly ran through and set the load date timestamp, record source. These are all the template columns. Because we have a simple, a very simple kind of setup here. We're not looking at anything too complex, but typically your system would have some better defined rules. So again, you start with source data, and this wants to look for the first record in set so that it can make sure that it gets that loaded, and then it gets all of your unique source records so that you can stage those as in a union form, so that you basically capture everything, but which one your most recent is up the top. So we were to look at this table. This is, again, so you have, your customer ID, created that. These are all the other columns that are tied to that cart hub that we can go back and track. So, and then I think we only have one more, and then we're gonna just actually take a look at the model as built, which is the link cart customer, which fortunately is a little bit quicker to roll out. But again, a little repetitive on these. Set source primary key, same thing. Okay. And this is where you pull out all your foreign keys to this link table. So,
Okay.
Source foreign key. And this is an array. So you're going to have cart and customer primary key are going to be the ones that are set up as your kind of your linked business or linked keys here. Last one is
okay. So you're basically creating a combination key that's a hash that you're managing through here. Is that right?
No, this is assigning the two columns to kind of live in this table so that they can be referenced.
Okay.
So,
I got you.
Yeah.
Okay.
So and also I misentered this one. This is the primary key of this table is that link customer cart PK. This is the concatenated key.
Okay.
So this is the unique combination of cart and customer. And then the foreign keys, because the other two keys here are going to be both foreign keys out to the respective hubs.
Got it.
So now the source load date timestamp is load date. And finally, source record source. And so this is the logic that it's going to follow to create the link table. So again, grabbing the most recent version of this combined record, it's only going to pull that most recent one. It's not going to. It just wants the most valid link between these two. And then as you see here, it will take just the primary key of the join, the primary key of the join, the primary key of cart, customer, and then the actual metadata of those records, so that you can have that audit trail back. So now that we've kind of built out everything, I'm just going to call the 2-word command, which is just dbt build, and we're going to see that what it does is it stages all the models right in here. So it knows that it does all the raw tables first, then it does the stage, and then I broke something because we probably didn't bring up cart hash diff. Yeah, I forgot to add the cart hash diff to this.
What the heck, man?
I know. Is hash diff. So you just specify that it is a hash diff, and then you add the columns. Which is literally just customer ID. Cool. So now we got that. dbt build.
Yay. Here we go.
It would be a live demo if everything went right.
That is spot on.
So as you can see, it's loading, and you notice the sats and links and hubs, they're all kind of coming in as needed because they're not dependent on one another. But at the bottom, we do have this dim address, customer order, product, fact order details, which I didn't touch on. Those also got built right down here. So just to show you how those were structured, because we touched on just kind of the overview of how do you build a dimensional model out of this. Well, your hubs and their related satellites are going to be, those are your dimensions, and they're very easy to join. The one that, and this is where people kind of fall out of love with Data Vault, is when you get to build a fact record. Well, that's a lot of joins right there. You're joining a lot of tables because this is really inefficient to write a ton of highly detailed, reportable queries off of Data Vault. This is why this doesn't belong in the gold layer. But if you're writing it for this kind of Kimball data model, doing this is, this is manageable if you're doing it in the one spot where you're siloing the logic and the joins. But you really do have to start off with your satellite link, the satellite link tables, go out to get all the detail information so that you can get basically your order, your foreign keys to cart, product, address, order. And this takes you all the way out to your customers as well to get the, essentially get your, quantity, price, line total, your very simple order metrics out of here.
Wow. So that's fantastic. So you're like, we go from here in the silver to our gold, which are views that sit on top of this.
Yeah.
Right. Is that how that works? Yeah.
Right. So if you were to look at this, the tables, and the reason, just a very silly reason to do it is it's easier to see in here, is I have the dims and facts in my view listing because this was just created just now when we ran that. So now we have this view, we can see the data preview, but you also have all of your hub, satellites, links, and stage, as sitting as tables, so that's sitting there as the foundational layer for your data model. So the change history, all of the, if you want to capture slowly changing dimensions, it's a lot easier to build off of a satellite table because all that change is sitting there ready for you to build and model.
This is fantastic. And how sure are you that this will work in Power BI?
This will work in Power BI. So you can connect Power BI directly to Snowflake, and as long as you're pulling in the star schema model and not the hub links and satellites, like that's one thing. I would not pull hubs, links, and satellites into Power BI. That's just highly inefficient.
Yep. Because it's all a star schema based. And,
Yeah.
Oh, I'm thinking of a different demo. Forget it. Thought I was setting you up for something. I'm not. Sorry.
No, we got plenty of sequels to all this. There's going to be a lot more to talk about, I'm sure.
Oh, this is fantastic.
Yeah.
All right, man. This looks great, right?
Yeah.
So we went from DBT. We used some modules in DBT to go from raw to create our entire data vault schema, and then we put views on top of that to create our star schema on top of that. Is that
That's
right?
Yeah. So you have your bronze, you have your source, raw, and then you got your bronze with that staging layer that this built. So this really went from bronze to silver for you. And then that silver layer being your data vault layer. And again, this is in certain climates, this works. In certain ecosystems, this really works. And in others, it wouldn't make sense. It wouldn't make sense to put in all that effort to maintain, not to mention to train up an entire analytics department on how do you maintain this if they're used to something else.
Well, and I think that especially as a lot of companies start to grow and expand, it was at one point in time, it was just like these large enterprises that were having to worry about adding in new companies and managing these different sources as we go along. But I think even small companies are running through that, right? Like, okay, they're using Salesforce, but then all of a sudden they realize that's too expensive, so they want to get everyone on Dynamics. Oh, there's a transition there. Well, what do you can't like stop using Salesforce while people are going on Dynamics. So now you have two source systems that you're trying to manage and juggle. Data Vault is great with that. All right. That would be a fantastic way to bring that stuff together. Right.
Oh, yeah. No, I mean, as far as bringing legacy data into a new, rollout, a new transitioning to a new system, it's a wonderful way to integrate those two things, and also to show an evolving business process, because you can change your business logic as you go, as long as these foundational pieces are in place.
Yeah, this is really fantastic, especially like you think about like some of the analysis that people need to do, right? Like, oh, I need to know who's the sales manager today. Great. But I also need to know who is the sales manager at that point in time, right? Maintaining that is, maintaining a type 1 and a type 2 dimension, or more importantly, a type 1 join and a type 2 join, I think makes that incredibly powerful, right?
Yeah. No, it really does, because
Yep.
and that's the vault piece of this, is you're not throwing things away. You're just storing it away for later use when the business need arises.
Yep. Oh, I'm a big fan. We are approaching the hour mark, so we do like to hold this to an hour. So I want to thank you, John, for all of your hard work on this. I know you've been putting in tons of nights and weekends on it, preparing this demo for us. So thank you very much. Any parting words for everyone before we sign off?
No. No, but thanks for having me, Chris. It's always great to talk to you. Hopefully we'll do this again soon.
Yeah, 100%. And thank you, everyone. Donald, Paul, Belinda, James, everybody who's in the chat. If I call you out, apologies. Thank you for joining us today. This is a fantastic topic that we don't talk about. Like, we spend all our time talking about the star schema, and that is great. We got to talk about that. But this is something that we really need at that silver layer in so many places. So, John, thank you so much for spending time with us and going.
Yeah, thanks to you. Thanks everybody for joining. Appreciate it.
Yeah, you guys all have a great day. Oh my gosh, I didn't cue up my music. Baker Tilly Digital combines strategic industry insight and advanced technical expertise to uncover and solve your digital transformation challenges. If you're interested in learning more, check out our website at bakertilly.com/digital.